This is an example using the multiplicative rule, and hopefully up to this point you've seen that the multiplicative rule is, suppose I've got two events A and B, and I want to compute the probability of A intersect B. And I can't get that probability straight up, or I can't get it through the addition rule, which is often the case. So the multiplication rule, or multiplicative rule, allows me to get to it. And the way I do that is the probability of A intersect B is the probability of B given A times the probability of A. Now that's one representation of it. The other representation is that the probability of A intersect B equals the probability of B given A. I'm sorry, I just did that. The probability of A given B times the probability of B. Both of these are results of the conditional probability rule that you have studied up to this point. But in this example here, I've got a physical fitness class. There's 95 students in it. And this table has helped me partition the class in terms of males and females, as well as the class of the student, if they're a freshman, sophomore, junior, or senior. And the question here is, what is the chance that a junior female and another junior female are chosen at random? Okay, so the instructor is going to choose two students at random for some activity, suppose, and what's the chance that that two junior female students are chosen? So what's going on here is basically the probability of the intersection of two events. So the first event is that a junior female is chosen on the first, we'll say on the first draw by the instructor, and then a junior female is chosen also on the second draw by the instructor. So I'm looking at the intersection of these two events and that probability. Well, the multiplicative rule, looking back up here, says, okay, I want to rewrite this sort of probability in terms of a conditional probability in times a single probability here. Now, the deal is you have to figure out, okay, the trick is figuring out which event do I condition on in order to represent the conditional probability. Now, if you recall, the way I think about the probability of B given A is, that means the event A has happened. Now that A has happened, what's the chance that B will happen? So B given A, or given the information A, is adding a restriction to the problem, or adding extra information to the problem. So in the context of a given problem, you want to know what makes sense, what event does it make sense to condition on? And when I think about this problem, this is a two-step process. One student is chosen, then another student is chosen. The event that I would condition on is what would happen in the first choice, or the first choosing of the instructor. And that would be that a junior female, or JF1 as I have it, was chosen first. And so when I think about the probability, this conditional probability, it's the probability of a junior female on the second draw given that a junior female was drawn first. Okay, and then the rule says you multiply that conditional probability times the probability of the event that you conditioned on. So I conditioned on the event that I drew, or that the instructor drew, a junior female student first, and so that's the probability that I have here on the right hand side. Okay, so I'm going to work with this one before I compute this conditional probability. The probability that the instructor would draw a junior female first would be, well, the number of junior females divided by the number of total students. And we see here that there's 95 students in the class, and we see we see here that there's 20 students that are juniors and female. So there's 20 out of 95, that's the probability of drawing a junior female student first. Okay, now it's conditional probability. It says, what's the chance that I draw a junior female on the second draw given the first draw was a junior female? Okay, the first student was drawn out of the class, and so that means there's now 94 students left to draw out of. And more than that, there's not 20 junior female students, but now there's just 19 because this has happened. So I've got 19 ways or 19 outcomes in this event given that this event has occurred. So this intersection probability is a probability, or is the product of these two fractions here. And you can do a little work to see that product is 2 over 47, which is the same as is approximately 0.043. Okay. Well, I hope this is helpful in building your toolbox of probability rules, multiplication rules.